Eric Burgess here, and we have been asked to take the derivative of the natural log of cosine x times sine y. So this one's got a chain rule, but in here we've got a product rule, and right here we've got a y, which means we're going to have some sort of an implicit thing. So this is going to be a fun one. We're going to see how well you know your chain and product rules. So just looking at this, we'll just take the first derivative. Well, I guess that's the whole problem. We're going to take the derivative though. So we get y prime here. The derivative of the natural log is 1 over what's inside the natural log. So we're going to have cosine x times sine y. But then it's going to be multiplied by the derivative d dx of cosine x sine y. So the first chain rule is not that bad at all. It's just this. But the next one is a product rule. So let's go ahead and do this one. I'm just going to do it sort of down the side, and then we'll come back to where we're at. So to take this derivative, we're going to take derivative of the first. The derivative of cosine is negative sine x times the second, which is sine y, plus the first, which is just cosine x, times derivative of the second, which is positive cosine y. But this derivative has a function in it. It has y. It's not just x. And because it's y of x, that means we're going to have a y prime come out. And this is going to be the result here. So that's the next derivative. So the rest is just going to be simplifying. Since this is multiplied 2, we can just go ahead and stick this on top of the fraction. So our new result is going to be, is there any simplifying we can do here? Anything? Doesn't look like it. We're going to get negative sine x sine y plus cosine x cosine y y prime over cosine x sine y equals y prime. So here we need to get the y primes together. So I'm going to multiply by cosine x sine y to both sides. This will simplify out the denominator here, and the left side will become y prime times cosine x sine y equals, and then all that stuff that's up there, I'm just going to put quotients. So now that all of basically the top piece is over there, we're going to move this bit over since it has a y prime. So we're going to get y prime cosine x sine y. I put extra parentheses up there because I didn't notice that there was no addition. So that's just a habit. Y prime, and then we're going to subtract cosine x cosine y. Y prime is equal to negative sine x sine y. So using this, we could factor out the y prime, and we get cosine x sine y minus cosine x cosine y, close this, equals negative sine x sine y. And this is a curly brace. It looks kind of like a bracket. Doesn't matter too much. All right, now we can just divide out. We get y prime is equal to negative sine x sine y over this big thing, cosine x sine y minus cosine x cosine y. And this is the answer. This would be where we can stop. There might be a way to simplify this. Let me look at it. So one thing we could do is we could factor out a cosine x. So let's keep going. Let's simplify a little bit. there might be something else we can do here. So we'll be left with negative sine x sine y on top. But we notice that we can take a cosine x out. And we'll be left with a sine y minus cosine y on the bottom. And we can combine this cosine x with the sine x, and we'll get this form. We'll get a negative tangent x sine y over sine y minus cosine y. And oh, look at this. We could be extra sneaky. Okay, so you could stop here too. I actually think this is probably where I would pull the brakes and be like, yo, this is good. I'm going to run with this. But there might be one more thing we can do. So since these both have sine y's on the top and bottom, we could divide everything by sine y. And it would have the effect of turning this to 1, removing this entirely, and adding a cotangent right here, which could actually be pretty pleasant, I think. So if we divide everything by sine y, the top just becomes tangent x was divided by sine y, so the sine y goes away, over, and then this sine y would become 1, and this would be cosine y over sine y, and of course we can rewrite that, so we get negative tangent x over 1 minus cotangent y. So we've managed to really cram this thing together. In fact, if you want to go one more step, we could take this negative and we could flip it, and we'd get a positive tangent x here, and we'd get a cotangent y minus 1. So I'm prone to just sort of stopping with the negatives on the top. They don't really matter to me that much, but this is even more pleasant. So there you go. So you could have stopped up here, but there was actually quite a bit we could do to really just squish it down to its most compact form. If you have any questions about this, feel free to let me know. Subscribe and hit that bell icon for future videos, and we'll catch you in the next problem.